Hello, I'm Shannon Morgan, and this is my Module 3 video presentation for lab. This is the molecule I've made to mirror the compound A on the lab handout. In the lab handout, hydrogen is oriented towards you, the OH is oriented away from you, with the COH group on top and the methyl group down to the left. The original compound has an S configuration, with the OH being CIP priority 1, the COH being CIP priority 2, and the methyl group being 3. This goes in a counterclockwise direction, which leads us to know that it is labeled an S with rotation. Now, for option A, it shows that the hydrogen is aimed away from you with the CHO group in the front, which leaves us with an OH group on top and the methyl group down to the left. However, the handout shows the methyl group on top and the OH down to the left. Since this is the opposite, I can conclude that it's an enantiomer, and this enantiomer has an R configuration, since the 1 is on top, 2 is on the right, and 3 is on the bottom left, and it goes in a clockwise direction. Option 2 shows the OH molecule oriented towards you with the H molecule in the back, which leaves CH3 on top and the COH down to the left. However, if you turn this around again, you still have compound A. So this compound would be, or this choice B would be identical and also has an S rotation. The third choice orients the hydrogen towards you with the OH in the back, which leaves the methyl group on the bottom right and the COH group on the bottom left. However, in the handout, it requires the CH3 would be on the bottom left and COH on the bottom right. Since it's the opposite, it's concluded that this is an enantiomer of compound A and it has an R rotation. For the experiment, this was the setup I used. I lined up my polarizing sheets so that the corners were equal. And then I rotated until there was no visible light getting through. I lined up my protractor, zero line with the bottom polarizing sheet, and turned my arrow to line up with the top corner of the top polarizing sheet. I observed that the L-alanine solution had the least degrees of rotation, which led me to believe it was a lot less optically active than the other two solutions. As you can see, I got a 1 degree observed rotation, which led me to a 20.83 degree specific rotation. Dextrose and fructose were much more optically active, giving observed rotations of 7 and 10 degrees, or negative 10 degrees for fructose actually, and a calculated specific rotation of 61.4 and negative 87.2. So the fructose is levorotary and dextrose is dextrorotary. I think that's the proper term. I had an error of 6.7% with the fructose, 11.6% with dextrose, and 38.9% alanine solution. That high error leads me to believe that maybe it's a lot harder to tell the optical activity of this particular solution with this simple experiment. And I'm actually kind of interested to know how specific different polarimetry experiments can be. Thank you very much.